Tonight's lesson is on rational and irrational numbers. Our goal is we can determine if a number is rational or irrational. So this lesson is pretty much vocabulary and identification. In class and on your test, you'll be asked to order these numbers as well. So make sure you're aware of how numbers go in order. And in class tomorrow, we'll have an activity that helps practice that. So rational numbers. The definition is a number that can be written as a fraction in the form a over b, as long as a and b are integers, and b, or our denominator, does not equal 0. In other words, it is a number that either terminates, which means ends, or repeats. For example, -14, which ends right at -14. We've got our 3/10 repeating. Okay, repeat, so it's good. You guys also know that can be written this way. A little repeating bar over the repeating digit. And as we learned in our roots lesson, the cube root of 729, which hopefully we know, equals 9. That's a rational number. Rational. It ends or it repeats. An irrational number is a number that cannot be written as the quotient of two integers. So it can't be a fraction. This is a number that does not terminate or does not repeat. And a good clue, pretty common irrational number. Any radical expression in which the number under the radical sign is not a perfect square, that whole thing becomes irrational. So for example, radical 15. We know that 15 is not a perfect square. Therefore, this number actually will just go on and on forever, no repeating. We know pi is irrational. We commonly use the decimal 3 1400ths for pi. That's a rounded off number. I think most of you have learned that pi just goes on forever. Then we have radical 122. Again, 122 is not a perfect square. So this entire expression is irrational. So that's it, folks. Just the definition of rational and irrational. Be prepared to order all types of numbers when we come to class tomorrow.